Okay, delta G, free energy. Delta G equals delta H minus T delta S. Delta G is the Gibbs free energy. It tells us whether or not a reaction is feasible. Delta H is the enthalpy change. Okay, so it's exothermic, endothermic. T is temperature. Delta S is the change in entropy. Okay? So if delta G is negative, then the reaction is feasible. If delta G is positive, then the reaction is not feasible at that particular temperature. Feasibility means whether or not the reaction will occur spontaneously without any additional help. And different scenarios will lead to whether or not the reaction is feasible or not. Okay? Some reactions are always feasible. Exothermic reactions with an increase in entropy, delta G will always be negative, they're feasible. Endothermic reactions with a decrease in entropy, delta G will always be positive, they're never feasible at any temperature. But some are temperature dependent. If it's an exothermic reaction and a decrease in entropy, then it will be feasible at low temperatures. If it's an endothermic reaction with an increase in entropy, it will be feasible at high temperatures. Okay, so if it's a temperature-dependent reaction, sometimes we want to find out what the temperature needs to be to make it feasible. So the point at which it goes from feasible not feasible is when delta G equals 0. So we put that into the equation, rearrange to find T. T becomes delta H over delta S. You put in the values, you've got the temperature at which it switches between feasibilities. Units are important here. Enthalpy is always kilojoules per mole, temperature is kelvins, delta G is kilojoules per mole, and delta S is kilojoules per Kelvin per mole. And that means that you have to sometimes divide it by 1,000, because sometimes in the exam paper they give it to you in joules per Kelvin per mole, but it's got to match up with the other units.